So, dear students, we can move with question number 16 of Neet 2019 question paper. Number 16. A body weighs 200 Newton on the surface of the earth. How much will it weigh halfway down to the center of the earth? So, we must know how that gravity varies when we move from the surface to the center. At a depth d, we can say that g dash take the value equal to g at the surface into 1 minus d by r. How much will it weigh halfway down? So here the d take the value as r by 2. So we can write as g into 1 minus r by 2 into r. So g into 1 minus 1 by 2. So if you just multiply the mass there, you get the value for the weight. So W dash is equal to W on the surface by 2. At the surface it is given as 200. That division by 2. So equal to 100 Newton. So we can take the answer as 4. So you just, but don't confuse with the altitude variation. So there at a height h, you get with the factor 2 here. So g dash is equal to g into 1 minus 2h by r there. But here it is depth, then this is the relation. Number 17, a good concept. The 6 similar bulbs are connected as shown in the figure with a DC source of EMF E and 0 internal resistance. The ratio of power consumption by the bulbs when all are glowing, and in the situation when 2 from section A and 1 from section B are glowing. So keep in mind, when all are glowing, in the sense we can consider this as a circuit like this one. That means here these three are in parallel. So keep in mind the very important concept. In parallel combination, the powers are added together. That is a very important concept. And in series combination, keep in mind, as 1 by P, take the value as 1 by P1 plus 1 by P2 plus etc. So here in parallel, and hence if each one got the value of P, and we can say it is net effect, it is equal to 3P in series with the 3P. So here these 3 together 3P, these together 3P. So but they are in series. So in series the effective power become. So simply we can say for n equal, we get the value as 1 by Ps is equal to n by P. So Ps is P by n. So here 2 equal values by 2. So 3P by 2. So the power effective for the first case is we can say 3P by 2. But in the second case it is given in the situation when the 2 from A, only 2 from A and 1 from section B. So that is a very important one. So 2 from A. So these are in parallel but in series. So 2P, but with a resistor we can consider as like that. So P. So when they are in series, you can get the value as P1, P2 by P1 plus P2. So that is equal to 2P into P by 3P. So you get the value 2 by 3p. So that is the second condition, effective value. The initial value as a 3p by 2. The second value as a 2 by 3p. Our aim is to find what is the ratio of power consumption. So the first case it is a 3p by 2 and the second case as a 2 by 3p. So pp cancel, you get the value as a 9 by 4. So we can call the answer as 2. So here it is a very important concept. While considering in parallel, the effective power is the sum of the individual. But in series, we have it to take as 1 by p is 1 plus 1 by p2 plus x equal to. So the reciprocalism we have it to consider. So a good question, number 18. For a p-type semiconductor, which of the following statement is true? And keep in mind the simple concept for a p-type and n-type semiconductor. The majority charge carriers here for p-type as holes. Here n-type it is electrons. And hence the minority here become electron and here it becomes holes. And keep in mind for intrinsic semiconductor that the more importance the addition of dopants. That is the reason why it become intrinsic become p-type or n-type. So the dopants added to the p are trivalent and are called as acceptor ions. And that dopants in n-times are called pentavalent, and they are called with a name as simply donor ions. You should keep in mind some of the examples. For trivalent impurities, we can say that indium, boron, aluminium are the good examples. For n-type, arsenic, antimony, bismuth are example for that n-type. But here the questions, which is majority and dopants are there, which are they? So here we know p-type semiconductor. So here the holes are the majority charge carriers and the trivalent atoms are the dopants, and hence we can say 2 as the answer. A good but simple question. Number 19. Again a simple question. Average velocity of a particle executing excitation in one complete vibration. So you should know. So you know the displacement is to take the value as x is equal to a sin omega d. If we differentiating one time the displacement, we get the velocity as is equal to a omega cos omega d. But keep in mind it starts from here like this one. So we can say the extreme position at the mean position, that is equal to cos 0 become 1. So got the maximum value. But here it is for one complete revolution. In complete revolution, we can say that the average velocity is nothing but equal to the total displacement by time. So we can say it is equal to the total displacement becomes 0. So we can say the 4 as the answer. A simple concept. Number 20. The unit of thermal conductivity. You should now go through the conduction process. The law of conduction. And suppose we are considering a rod having a area of cross section, a length, depends with the temperature T1, T2. The rate of flow of energy is proportional to the area of cross section, the temperature gradient dt by dx, and that proportionality constant, and that is called the coefficient of thermal conductivity. So we have to find the unit for K in terms of joule or watt, like that. So K take the value as dq by dt by A into dx by dt. So dq by dt is joule by second, meter by meter square, the temperature dt as Kelvin. So joules per second we can take as watt, meter raised to minus 1, Kelvin raised to minus 1. So 4 as the answer. Good question is waiting. Number 21. A solid cylinder of mass 2 kilogram and a radius of 4 centimeter rotating about its axis at the rate of 3 rotations per minute. The torque required to stop after 2 pi revolutions is. So it is going to rest. So the good concept implies a v square equal to u square plus 2as in linear. Here we can use as omega t square equal to omega 0 square plus 2 alpha into theta. So it becomes a rest, and hence we can return 0 equal to omega 0 square. And here the going to rest, so alpha should be a retardation. So 2 into, again you know, as twice equal to I alpha. So alpha can be write as tau division by I. So tau by I into theta. So we can write as omega 0 square equal to 2 tau by I into theta. So tau is equal to omega 0 square into I division by 2 theta. That is equal to, what is omega 0? You know the relation as 2 pi n. Here 3 rotations per 2 pi into 3 rotations per minute. So 3 by 60. So on squaring, we get as 4 pi square into 9 by 60 into 60. What is I? The moment of inertia for the cylinder, you know, mr square by 2. What is m here? The 2 kilogram into the radius as 4 centimeter. So 4 into 10 raised to minus 2 the whole square. That division by mr square by 2 into 2 theta. So 2 into theta, a good important concept. Here it's 2 pi revolution. The one revolution take the value as 2 pi radian. So 2 pi revolution take the value as 2 pi into 2 pi. So we can say as 4 pi square. The 4 pi square cancel. So 9 into 16 into 10 raised to minus 4 by 2 into 36 into 10 square. 4. So 2 into 10 raised to minus 6. 2 into 10 raised to minus 6 Newton meter. So we can code the answer as 1. So this equation, it is very important. So we can just relate to such problems with the kinematics. So we get the answer so easily. Good substitution. Number 23. Number 22. A force F is given as a 20 plus a 10y acts on a particle in y direction, where F is in Newton and y in meter. Work done by this force to move the particle from y equal to 0 to y equal to 1 meter. We can simply use the integration method for variable force as a W is equal to integral F dy between the limit y is equal to 0 to 1. So it is given as F is 20 plus 10y into dy. So equal to integral 0 to 1 20 dy plus integral 0 to 1 10y dy. That is equal to 20 y between the limit 0 to 1, 10y square by 2 between the limit 0 to 1. So that is equal to 20 plus 10 by 2 as 5. So you get the answer as 25. A good concept. So we get the answer as 25 joule, 3 as the answer. Number 23. Which of the following act as a circuit protects device? So it's a good concept, and keep in mind as a fuse wire, the fuse wire, and is connected that fuse wire in series with the electrical appliances which is to be protected. And keep in mind, and that fuse must got a special concept as it should got low melting point and high. The very important concept that safety fuse must got low melting point, but it should fuse or break. It becomes a circuit break very instantly, and hence it is made with a combination of tin and lead alloy. Tin lead alloy. The very important concept. And see, so the fuse wire is used as a circuit protector. The question number 24. In the circuit shown below, the reading of the voltmeters and the ammeters. So here, the 10 ohm resistor is the V1, that is A1. The 10 volt is connected. And here again 10 ohm, here 10 ohm. 10 ohm, here 10 ohm. But the voltmeter is here, V2. But we know ideally the voltmeter, that is a very important concept, got infinite resistance. But for ammeter, ideally it got a zero resistance. The very important concept. Then we can move with that. So at first one we can just think about the voltmeter reading for the both. So we can avoid that amp because of the infinite resistance. So it is equivalent to a gap. So this can be cancelled and this can be cancelled. So in the first circuit, and it is equivalent to a 10 ohm that is connected to like this one 10 volt. So and we can easily say that volt V1 is. And what about the second case? Again at that case the same circuit. So V1 should equal to V2. And the second case, what about the current? In the same case, if you just consider the current flow for the two ammeters, the same circuit is retaining, and hence we can say that I1 should equal to I2. So we can say 3 as the answer. Number 25. A hollow metal sphere of radius capital R is uniformly charged. The electric field due to the sphere at a distance R from the center. And keep in mind, if you just consider an outside point, all the charges are concentrated at a particular point center, and hence E is equal to K into Q division by R square. But if you just draw a Gaussian surface well inside, there is no N charge enclosed, and hence the electric field should equal to 0. Therefore, its variation is like this one. The inside value is 0. On either side, it goes on like this one. So that is the curve. So we can say 0 as R increases for R less than capital R. And then what happened? E proportional to 1 by R square. So decreases. So for the question number 25, you can code the answer as 2. As R increases, 0 s r increases less than r, and for r greater than r, the value of decreases. That is a very important concept. Number 26. At a point on the Earth's surface, the angle of dip is a plus 25. At a point B, it is minus 25. We can interpret. And keep in mind, what is the basic reason behind the earth magnetism? There is an assumption. In the northern hemisphere, or a huge magnet is buried, and in that magnetic dipole, that north pole of the magnet is in the southern hemisphere, and the south pole in the northern hemisphere. And hence what happening is this one. See, if you just consider the northern hemisphere, you know, the dip is nothing but the angle made by the total field with respect to the horizontal. And keep in mind there that total field in the magnetic meridian, see, makes an angle, so delta, that much value with respect to the horizontal, and is treated as the plus value. That is in the northern hemisphere. But in the southern hemisphere, so there, in the southern hemisphere, keep in mind, inside there is the north pole. So if you just place a freely suspended magnet, then it's a north pole pointing in the upward direction, and hence there, this is the structure there. The total field got the direction like this one. So this is the vertical component, and this is the horizontal component. And hence we can say, and this is that one, and is treated as negative. So that is a very important concept. So we can code in the northern hemisphere A, the plus value, and the minus in the southern hemisphere. So 3 is the answer. Number 27. The total energy of an electron in an atom in an orbit is minus 3.4 electron volt. The total energy is minus 3.4 electron volt. Its a kinetic energy and potential energies are. And keep in mind the shortcut, the very important concept. The total energy is, keep in mind, the minus kinetic energy, and also the very important concept, the total energy is equal to plus potential energy by 2. Potential energy by 2. So here the total energy is given. So the kinetic energy, take the value as minus the total energy. So minus into minus 3.4 electron volt. So we get the value 3.4 electron volt. And the potential energy is nothing but equal to 2 times of the total energy. So 2 into minus 3.4. So equal to 6.8 with a negative sign. And hence we can code the answer as a 3. So this relation is very important. The basic concepts, even it is applicable for our satellites motion, etc. Number 28. In total internal reflection, when the angle of incidence is equal to the critical angle for the pair of media in contact, what will be the angle of refraction? See, this is the denser medium under consideration. And suppose a ray of light is incident at this one. So this is the normal under consideration. At the critical angle, that refracted ray just grazes through the surface, and hence this is the angle of a refraction. So it becomes 90 degree. So we can say as 4 as the answer, and that is a very important concept. The sin C is equal to 1 by mu. It should be in your mind a good aspect. Number 29. The work done to raise a mass m from the surface of earth to a height h which is equal to the radius of the earth is. And keep in mind, the work done is nothing but the change in potential energy. A very important concept as mgh by 1 plus h by r. Keep in mind, you are using mgh always only when where h is very much less than capital R. Otherwise, that potential energy change is mgh by 1 plus h by r. but it is given that is equal to the radius of the earth. So h become r, and hence we can write as mgr by 1 plus r by r, so equal to mgr by 2. So you get the answer as 3. It's a good aspect. Number 30. An object is shot from the bottom of a long, smooth, inclined plane kept at an angle 60 degree with the horizontal. It can travel a distance x1 along the plane, but when the inclination is decreased to 30 degree and the same object is shot with the same velocity, it can travel x2. Then x1 is to x2 will be. So at the first case, it is with a 60 degree, and the next case, it is with a 30 degree. So that is a 60 degree, and another one has a 30 degree. So it is a shot. In the first case, it travels a distance x1, and the second case has x2. But keep in mind, a particle on an inclined plane, the weight mg is acting vertically and can be split into two components. So g sine theta, that is the acceleration along the inclined plane. So we have to find what is the displacement along the inclined plane. So the stopping distance can be easily find out as is equal to the initial velocity square division by 2 into acceleration as g sine theta. For the first one we can write, and for the second case that stopping distance as u square division by 2 into g sine theta 2. Therefore, x1 by x2 is equal to sine theta 2 by sine theta 1. What is sine theta 2? Sine 30 by sine 60. So that is equal to 1 by 2 by sine 60 as root 3 by 2. So you get the answer 1 is to root 3. The 3 as the answer, a good aspect. The stopping distance, but it is along the inclined plane, so the gravity component changes to g sine theta. So students, God bless you, take care, but we can wait for the question number 31 to 45. Thank you.